Hello everyone, I want to welcome you to my YouTube channel. This is Steve coming back with another video for the Commodore 64 videos. What I'm going to be showing you in this video is how to reverse engineer a game that I found on basically online in a place called Ahoy Magazine. And also you may notice I've got my computer back, so I'm pretty ecstatic and everything, so thank you so much, Mitch, for fixing it. And yeah, I'm going to get this moving forward. I've got some really great things for you tonight, today, wherever you are. And let's get started on that because do some reverse engineering and just some great things to come. Okay, so we're back. This is the actual game that I've actually taken apart. Now it's taken me, I'd say probably about 7 hours or more just to kind of put this thing in perspective. And I had to sit there and do a lot of re-engineering, reverse engineering, just a lot of work. I had no idea what this was going to be like, but now I'm beginning to really understand what it means to reverse engineer. But the good news is I've changed a lot of things in it, and I've played with it long enough where I think I understand it to a really good extent now. So we're going to go ahead and get that started, and also I'll just demonstrate it here for you. Hopefully I got... That's funny, I was actually grabbing my joystick. I meant to grab my Xbox controller, and I think I have to turn it on here unless it's paused. It's not paused or anything. Give me 1 second. Okay, so I'm back. Just to show you here, this is the original program or the original game. We'll just play it for a little bit. And I was wondering where the side effects were. When he hits the wall, he says ouch and stuff like that. Okay, I think that's the end of the game, or no? It's giving me some errors over here in the window here, so I'm gonna make this crash. It keeps crashing the window here. For some reason it keeps bringing up the debugger window right here. Every time it's crashing, it keeps bringing this window, so I have to keep shutting it down. Pause here. Well, for some reason my computer has been going crazy and it's been shutting things down, so just I'm reloading it right here right now. You can also see I got Pitfall 2 running in the background, so I'm pretty happy about that and everything, and just looking forward to, you know, reverse engineering this game real soon here. Okay, so we're almost ready to launch here. I just paused it. I'm going to leave my computer on to test it because it's got, you know, all new heat-sinking boards in it. And yeah, give me 1 second. Okay, I'm back. Got it working again. I'm going to try to kill myself here to show you the end level. So there's the end level. So keep in mind the end level just shows over and it kind of darkens out the screen. And if you press any key, it starts over again. Now, I'm just asking you to pay attention to some things here. So, essentially, I think you've kind of got the grasp of it. I changed some things. I changed the sprite. I changed the energy bar, and I changed the end game screen, and I changed some of the movement. And I've done some other interesting things. So, let's get started on that. Now, to mention this is the game character I've added into the game. Earlier you saw the Santa Claus, but when I run it, you're going to see all the new changes. So let me run it first, and then I'll demonstrate and explain it later. Okay, so now it opens up like this funny screen because I'm accessing a different part of memory for the sprites. But you said 6449 once, and you'll see it change here. And now, you notice I've got the frog. He's actually embedded in instead of the Santa Claus, and of course I can move around. The other thing it does is it auto moves now. So instead of just moving, now it's a little bit actually more challenging. Think about it. There is an error with it somewhere. and it jumps out, so I got to fix that. Here's the end part of the screen. You can see that I changed and I added a little, you know, color bar around it. Everything else is pretty much essentially the same, and I'll show you some hacks we can do. Hopefully we can figure out what it's doing and why it's crashing. I had to type this in all by hand because I didn't really have an assembler or anything to copy it over with. Now if anybody knows how to do that in Vice Monitor, because what I did here originally, if I go to Vice Monitor, I'll show you. I went here to the Vice Monitor and I went to the assembly window here, and I actually copied these all down by hand because you can't copy inside of any of this. It will not let you copy. It'll let you set breakpoints here, but you can't copy anything. You can copy in this window, but I don't know how to, you know, set this all up yet to copy all the code. Maybe I'll research that later, but if anybody knows for now, you can throw a quick link and I'll appreciate it very much. So, I'm gonna run this again for a second, and let me maximize this so you can kind of get a better view of it there. It's also running in multicolor mode there too now. I changed the color bar down here at the bottom. Also, this used to be green and I changed it to yellow, as I mentioned there. And I'll show you some hacks here as soon as I can get this thing to play. It keeps crashing. Okay, so it keeps getting stuck on the maze. Because it's like sometimes when you move it up now, it's playing with the screens. You can tell it's definitely entirely hacked here. Okay, so I'm trying to make it so he gets some points here so I can show you something. Let's stop for a second. Okay. So the mazes are also randomized. You get stuck on the thing every time. There was something I changed in the code earlier, that's why he's getting stuck. That's what I wanted to show you. So I've played with some funny things in memory, and I've changed the memory around. Now we're actually scrolling through memory. It's going to start doing some funny things when you start scrolling, because now it's messing with the character set, and eventually it'll just crash. Look at that. But we're running it straight inside of here, so it doesn't interfere with your program at all. So now to go in and see how I did this. So what I did is I showed you I took it all by hand, and this took me many hours to type in. And while I was doing this, I was learning a lot, because what I was doing is I was setting loops, lock-in loops, so I could go ahead and rerun the code over and over again after certain segments, so I could kind of see what it was doing as I was going through it. This helped me disassemble it much better. And I basically went here and I documented a lot of the code so I can understand it. So here, if I wanted to play with the sound, you can play with the sound right there. Sorry if I'm going too fast, so I probably should slow it down a little bit. But I'm not going to be able to explain every little thing because I haven't hacked apart everything, but you can see these are the registers. I'm just going to show you the parts in it, and I'll put this up on GitHub as always. I'm going to show you the parts that I totally understand so far, because I'm still in the process of pretty much disassembling it, reverse engineering it. So I kind of like just put in my own little notes here, so what's going on. These are basically controlling memory locations for 4689 and above, and this is just outputting a character. Here we've got where we were earlier, so basically this is controlling the voices. These are just the voices. You can change the sound. Voices are the sounds in your computer, so if I wanted to play with the sounds, I could change them by changing the bits that are being processed there to sawtooth, sawtooth, or random noise, whatever the other sounds are that are built into the Commodore 64. And down here is where I found out it begins drawing the map. And I'll show you something. So if you go in here and you change some of this, well, I think we kind of did that already, but if I change this anyway, this is where it's storing the map at. It's reading in those two high and those low bytes. Here, if I go in and I change it like this, it should do something really weird. It's basically going to change the way the screen looks. You'll see it instantly. See what I mean? It totally changed the way the screen looks because we're no longer looking at the area where they were storing the map. We're looking in a totally different area now. And this area has practically nothing in it. Eventually you'll see them get to the bottom here. So this gives me an idea. I could actually go in and I could start designing my own levels now that I know where this map is stored. and then there's the bottom, and it just crashes once it goes back up again. So that's demonstration 1. We'll put that back the way it was. Just hitting the Control Z to undo it. This is yet undefined. I really haven't gone in to figure out what this is, but I think it has something to do with the memory, you know, the map and stuff like that. And I just put moving through 49,152, which is exactly what this is doing. It's just changing the map. I haven't really gone in to mess with this stuff yet, but this is the color of the screen here. Usually you can sometimes hover it over here and you can see it, but my CBM Prg Studio isn't working right now. So anyways, D020, I can grab my calculator and show you how that's calculated. It's just appearing as hex on the, because that's how assembly language is processed. You write in hex code, and I'm finally starting to understand the reason why you should use hex code, because when you're basically reverse engineering a game, they're all going to be in hex already. So I think I totally understand why people do that now, and I'm starting to train myself to do it better. But anyways, let's go ahead and if you wanted to convert this, you can just go ahead and convert it, since my converter here is not working at the moment. And you just hit D020. Make sure to click on hex, D020, and you see it's 53,280. So this is basically controlling the border. I can put in here border color. So if I wanted to change the border color, I could go in here and I could change this. And I think this is what it starts at. It starts at a 1. If I wanted to make it black, I could just leave it at 0 or something like that. And it should start up black. See? The border's now black. Okay, and then this is the screen down here. So we're set currently to 6. We could put this to 1 and just change it to like a white background. Now it's a white background. But we don't want a white background. We'll just leave it blue. And then down here, I started writing down some more. This is a sprite shape. This changes our sprite. So if we go in here and we play with this value, it's going to change the way our sprite looks. Actually, it doesn't bring up anything because we only have our sprite turned on right now. He's kind of invisible. Let's see, he'll turn off when he kind of does stuff like that. So if we wanted to make them appear somewhere, let's see, we set it to D or something like that. Let's see if there's anything in D. It just depends on what's stored in 2040 at the moment. If you haven't written anything into that area, there we got a funny looking shape there. See, it kind of looks, and that's all that's doing. So we'll put it back the way it was. And here's how we change the color of the maze background. I think it's this one right here. You see it's currently set to 3. I think this changes the background surrounding of it, if I'm remembering correctly. I got an error message here. Oh. Why did I do that? I meant to do this. See? Now it's green. Like our frog, right? Everything else still works the same. So we'll put that back the way it was. And this is where it basically takes the 3 and it stores it in here. I think that should be number 3. I don't think that should be $3. But anyway, this is just changing the colors, and it just puts it into the maze. Here's some more of the scrolling. I didn't really do anything with this yet, so I didn't change anything with it. Okay, this section, let me see, change number 1 to see memory skull. So I said change number 1 don't know which one I'm talking about. Change number 1 to see memory scroll. I think if I put number 1 in, this is what I'm saying. And if you guys want to know, the address is system49160, in case you couldn't see that. Yep, this one's kind of cool. What it's doing is it's scrolling through memory. The map is more spread out now. Fun kind of stuff you can do when you start reverse engineering. Start playing around with things, you know. See if we get to enlarge this. Now he's turned into something weird here. Might have crashed. I think it crashed. Okay, so we'll put that back for now. Nothing doing here yet. I think this has to do with drawing the maze. Because it draws a random maze each time, so I'll probably have to go through it and see what part's doing what, maybe later. So here's where you draw the score palette shapes on the screen. And I wrote down here, draw score palette default is A0. So if I go in and I change this to something else, like 1 or something, you'll see them change into something different. And that's those things that you pick up. See? Now they're kind of like little A's. And I also forgot to put the other thing back, so I'm going to put that back real quick so I don't get lost here. Okay, so I got my maze back there. Okay, good there. And we've seen the pellets. Here's where you can change some of the sounds in it. If you, for example, wanted to change the sound, we could go in here and play with this frequency control. Not sure if 8 would do something, but I'm going to try it anyway. I think it might be one of the bits that it's going to use. Let's see if we can change the tone or something. Actually, they all got erased, it looks like. They turned invisible or something. They turned completely off. Okay. Let's put that back just to see if it goes back to normal. Yeah, I think I turned something off here. I'll pause for a second to put it back to normal. There, I put it back to normal again. And we'll go and play with the sound now. See if we change the sound. So that one seems to, I think that's the random number generator. I think that's why that one is disappearing. I think I learned something new here. That's just this frequency voice control, but it seems to be taking things away from the screen. If I set this to 8. Okay, so they're back. Just trying to change the sound of them. I think what it's done is it's reduced them. It's interesting. Looks like it reduced them. Does it look like it reduced them? There's usually more. Hasn't changed any of the sounds. Seems like it's put few and far between there on those. So that's interesting. I think I'm going to put that over here. Reduce pellets. Okay, so moving on. Here's where the score is, and I played with this one, and I finally figured out how to increase the score. So we'll go back and run the program again so I can show you how this is working. Got stuck on a wall again. There's still a bug in it somewhere. I'll have to fix it. So he gets stuck on the wall sometimes. Because I've been playing with it for a while and made it do some funky things. And so you can see I got 10 points, right? Let me just pause here a second. Okay, so we're back, and I was going to show you how to go ahead, and you saw earlier when I touched it I was getting 10 points for each item. Now if you change this based on this number here, 4, 5, or 6, you can increase the amount of points you're going to get. So if I wanted to get 100, I could just move that 0 over. So basically what you're doing is you're lining up zeros like on a score panel there. If you had imagined like zeros in a row, for example, like 0, 0, 0, like that. And then you're lining them up, so that this would be the, actually put the tens place, that'd probably be the ones place. The ones place, the tens place, the hundreds place, the thousands place, and so on. And that's what we're basically doing here, is we're figuring out which one to write the number into. So if we change this to 5 like that, it should allow us to get 100 points for each pallet instead. So basically it's all about the display, so whatever you're seeing on the display is how it's calculating. See, now I'm getting 100 points for each one. Earlier I was getting only 10 points. Keeps getting stuck on that wall. So it seems like when I push the controller down, that's what's causing him to crash sometimes. Okay, so there's 100. Those ones on the wall are harder to get to. There's 200. It's a pretty deep maze. 300, 400. So you can see I increased it by 400. Now if I wanted to increase it by 1,000, of course, I just changed the next number to a 6. And now we'll get 1,000 points. See, now we're getting 1,000 points for each one. It's stuck on the wall again. I'm dying on this one. You just getting stuck on the wall so much. I said I'll have to fix that later, somewhere in the code there. It seems like when I move it up and down, that's what causes it. So it's probably the up movement that's causing it. I believe that's what's causing all this stuff to crash on me. Waiting for a very long one. There we go. Now you can see I'm getting 2,000 points. Can you get this one without dying? So I got 2,000 points instead of just 100 and 200 points. So that's essentially what that part's doing. Just wanted to demonstrate that. Down here is where it's drawn the health panel. So right here, if we change this value here, it'll change the health panel. So let's put it to like a C. 5C. And look at the health panel. It totally changed. Used to have like that line going down it. Now it's got like a long bunch of squiggly lines there. Everything else still works the same because we haven't played with anything else. More safer when I go down. As soon as I try to go up, it goes wacky. Okay, so we'll put that back the way it was. And here's where we initialize sprite data, the sound volume, the multicolor. So here's how I basically got my own sprites, and here's the position. You could also move his position around. Let's say you wanted to move him farther over or something like that. We could probably put him way over here. I'll probably crash because he's land on a maze or something, but we'll see what happens. See? He used to be right here, and now he's totally over here. And the ouch is not lined up either. It's doing some weird stuff now. Totally strange now. It's because every time he dies, it's repositioning him back in the wrong place. So I'll put that back to normal. Run it just to be sure. Okay, we're good. And sprite color, you can change the color here. So we currently have a 5 color, which is a green for the background color. We could change it to something else, like make it a 7, like a yellow or something. Now the frog's going to appear yellow. Now he's yellow. We're just having some fun with this, aren't we? Put it back. Here's where you can change the multicolors. We won't go into all that, but basically just going to change these other background parts of the frog there. And the joystick data, more voice controls. Down here is some of the movement I found with the joystick. A lot of this stuff is still kind of undefined. Haven't really played with a lot of it yet. It's probably more the map drawing again. I think that what it's doing is it's probably drawing the directions of the map and stuff like that, depending on what random direction is being picked, because it's drawing a random map. So here's where he bumps into the wall. Ouch, bumped into a wall. And it says change 02 to bounce player. Put that back to 1. I did something very early when I was playing this. I accidentally, the bouncing wasn't something I programmed. There was something done by accident, and I've never been able to fix it yet. So I wrote that line down, but I couldn't figure out if that was the problem. I think he still bounces. Yeah, he still bounces. And it crashes actually now. So put that back the way it was. And this is just changing the border color again. More sound controls. Just see change color of border when hitting a wall. That stuff's kind of self-explanatory. Flash the screen. Instead of flashing the screen, we could flash the border. But we're already doing that anyway, so. And down here it spells the word ouch. You notice when he hits the wall it says ouch. We could go in here, we could program this if we wanted to use like our own name or something, or you wanted to change it to something else. Okay, so I'm running again to show you what I did to it. You might not be able to see it, but if you look real closely there, you can kind of see it for a second. Punk. I changed it to punk, so see P-U-N-K. So this is kind of fun stuff you can do when playing with the program. Put it back the way it was. And this part's still kind of undefined. Here's some more about the score. You can change the score. You would never really want to play with this, but you could play with this if you wanted to. It's just going to change the zeros to different, like different numbers or characters, whatever you put in there. I think I might have put a character in there. Okay, not sure what that did, but it was interesting. So here's some more screen controls. This is storing something here based on whatever this value is in here. Sometimes I just like to go in and just do something like that and see what happens. That's the whole point of reverse engineering. Sometimes if you don't know something, you just play with the value and change it, and you never know what you're going to get. And sometimes it might help you discover something else you didn't understand about the program. Yeah, it's kind of, I think it's changing the positioning of the where he's moving when you're moving him around. It's probably something to do with the scrolling or something. Now he's just landing on top of the maze every time. Yep, I'm not going to get very far with that part, but anyway, put it back the way it was. Here's where the energy bar is being drawn on the screen. And I think it's this one if you change it. This changes what it looks like. So if I wanted to change it to something else, I could just grab my book here and look through what's called the screen codes here. If you can see that or not. These are the screen codes that are built into your computer's memory, and you can go ahead with that number beside it. You can change your whatever you're going to see on the screen there. So it's basically what's displaying when you're peeking and poking to the screen. So let's just say we wanted to change the energy to like an @ symbol or something. We could just put a 0 in there. If I'm in the right place, it should work. So it actually changed that. Yeah, that is the energy. Watch. As it grows, you'll see it. I'm stuck on the wall again now. See? It turned it into like a number sign instead of a bar. And down here, this is where you turn off the sprites. So when it's over, at the very end of the screen where it wrote over, it used to say over, but I changed it to my name and put hacked by Steve. And I put the year in it. So this is basically my inserted message right here. I just took this message from here, game display, and I have to search. So right here, what it's doing is going down, reading the high and low bytes here of this message right here where it says hacked by, to get it to display on the screen. So that's how I got the hacked by message to display on the screen, and just reading it into the high and low bytes of 0 page to write it to the screen. This part I don't even need anymore. And then down here, I put 1523 energy pellets. I'm not sure what that's for. It's changing, find out. This will be for the end of the game, so we'll have to make it end of game. Won't be too hard lately. It's been crashing so much on us anyway because we've been playing with it so much. Oh, interesting. Like turned off the map or something. So what it is took out the S in my name, it looks like. that was coloring in. I think that was, oh, that was putting in the background. So I wrote Steve on it. This is my name on the screen. So you could go in here and you could write your name in here with the letters, and it just prints them, you know, across the screen. So it's F4, F5, F6, F7, which is just one after the other. So for those who want to know decimal, you just go over here to the converter and just 05F3. And you can see it's 1523. So if I brought this on the screen and I poked in 1523, and then I put in that value there, which is 29. If I had to convert the value there, which is, oops, 41. If I put 41 there, that didn't seem to come out right for some reason. Anyways, this is how you print the messages on the screen. So I didn't want to waste a lot of time on it, but here's my hacked by message right there. I just kind of wrote it to the screen and wrote it out. Here's the 2016 message underneath it. And this is where it waits for the game to be pressed. And you saw that flashing border at the end of the screen. If I wanted to put them both in, I could do both with the border like this. Actually, that's bad programming practice that I did that. Stick with the hex stuff and run it. And it'll flash both the border and the screen when the game is over this time. Crazy, huh? Now we're flashing the entire screen. Okay, and these are no ops right here, or no operations. This allows it to pause. So if I wanted to create more of an illusion effect, I could sit there and do more stuff like this, more of these in there, to set the timers. And then it'll give kind of a different scroll effect. There's other ways you can play with the tick timer too, but I just wanted to show you this just for quick purposes. Let's crash into game again. See, it's got like kind of a different color effect now. Okay, so down here, so what these bytes are for, I don't think I even need these here. I don't even know why these are here. This is just a loop I created originally when I was testing it, and I didn't want it to crash. I'd set it inside this loop so it would stay inside of this loop and print out stuff on the screen so I could kind of make sure it wasn't crashing into the program and I could still see these messages. So if I had these messages printed on the screen, then I knew that it had not crashed somewhere in my code and it had reached this routine. So here's the hacked by message. We saw all that. So yep, that's pretty much the whole program hacked apart. Santa's busy day. And I didn't explain this, but these are the sprites here. So you see the frog sprite here. This is basically just loading in the raw data. So I just went up here and I exported it like this, PRG file. And then I just set it to memory location 380 like that. And you set this to raw data. And then you just go here and you save it. So I'm going to demonstrate something real quick here. Actually, it looks like it did fail. Okay, so this one definitely took a while to play around with. I finally figured out I just had to use the original file. I couldn't create my own for some reason. So I paused it here, and you can see I've got the little eyes on here, which is this one right here. So if I go in here and I unpause it, you can see I can move around with the eyeballs. So that's all I was going to show you for this video. I hope you guys enjoyed this session. So yeah, guys, I enjoyed making this video as much as I could. I just hope you guys enjoyed this and learned something. Like I said, I'll take the example and I'll put it up on GitHub so you guys can take a look at that. We'll be doing some more stuff like this. Now, I had the game running until it probably timed out and me in the background, the Pitfall 2. I'd like to eventually try to take that one apart again and actually get it into CBM Prg Studio or something similar that I can work with. So what I'm going to do is I'm going to spend a lot of time with that. Now I have another device I've ordered here, which I might have mentioned this before. It's an SD card that hopefully it'll allow me to get programs off my Commodore 64 onto my desktop, or do something like that very soon, because I'm just really looking forward to moving ahead here as much as I can. So I hope you guys enjoyed it. Like this. Please like, favorite, subscribe as always, and thanks for watching, guys. Appreciate you so much. Bye.